add this to your notes, section 2.5, I think we're talking about. And we're going to talk about second implicit differentiation. So, second implicit differentiation. And I am going to start off by just giving you guys an example, like you should already know how to do. So let's say I say x squared plus y squared equals 25, and your job ultimately is to find the second derivative. So before you can find the second derivative, you need the first derivative. So let's go ahead and find it first. Remember, you always find the second derivative with respect to x. So if you have a y in there, you find the derivative of the y, but you have to tack on to the end of it dy dx. Same rule as before. So what is the derivative of x squared? It is 2x. Plus, the derivative of y squared is 2y. Very nice. Dy dx is equal to, what's the derivative of 25?
0.
It is 0. All right, got to solve for dy dx. So I'm going to subtract 2x from each side, leaving me with 2y dy dx is equal to negative 2x. I know I'm going through this quickly, but I feel like you should be able to handle this. Divide both sides by 2y. The 2's cancel out. It leaves you with dy dx is equal to negative x over y. Are you okay with that?
Mm-hmm.
That is the first derivative. Your job now is to find the second derivative. So when you're finding the second derivative, first of all, there's a notation for that. You're finding the second derivative. There's like an understood one there, first derivative of y. So if you're finding the second derivative, you need to change it so that it is d squared. It's not really called d squared, it's called the second derivative, but it looks like a d squared. So when you're finding the second derivative, you write it like this. On the bottom, you have to square the x, and I'm not sure why, some famous mathematician years ago decided that the x had to be squared too. Yeah, I guess. I don't know. Yeah.
Oh, never mind.
So, if you were going to find the derivative of this, of negative x over y, what do you have to use? The quotient rule. So let's do it. And every time you find the derivative of a y, you need to tack on dy dx. So the second derivative of that thing is going to be the denominator, which is y, times the derivative of the numerator, which is negative 1, minus the top, which is negative x. What's the matter?
I just got lost.
Hold on, I'll back up here in a second. Okay, so this y, the y, are you back on track?
Well, I was like trying to catch up. So where the d2y did that come from?
Well, this is the first derivative. Dy dx is the first derivative. We're finding the second derivative, so we need to find the derivative of the first derivative. This is the notation that we use for the second derivative. Second derivative, that's why there's a little 2 up there. Not sure why there's a 2 next to the squared on the bottom. Don't know, okay? All right, so we have y times negative 1 minus negative x times the derivative of the bottom, which is 1 dy dx.
Do we have to write the one?
No, do not have to. I just like to have it in there for those of you that might not know where, or maybe forgot that, or thought that I forgot to take the derivative. What goes on the bottom? Y squared. Dy dx? No. Didn't find the derivative, you just square the bottom. All right, equals, let's clean this up a little bit. Y times negative 1 is negative y. We have to distribute that negative into the x, so we're going to have plus x times 1, stays the same, dy dx. Now this is ugly, and this is really ugly because we have a dy dx, something very awkward right in the middle of an already complicated rule. So what we're going to do is not forget what we started with. dy dx is actually negative x over y. So what we're going to do is take that negative x over y and we're going to plug it in for dy dx in what we have right now. So equals negative y plus x. I'm going to replace dy dx with negative x over y divided by y squared. And I just have to clean it up a little bit, and I'm starting to run out of room. So I am going to try to squeeze that over here. Squeeze that in over here. So we have negative y. We have x times, now remember this x is the same thing as x over 1. So we have x times negative x on the top. That's going to be a minus x squared. Divided by, and on the bottom we have 1 times y, which is y. And then all of this is going to be divided by y squared. That's ugly. So I think what I suggest doing now is think about this as y over 1, negative y over 1. Do your cross multiply thing to get your common denominators. So we're going to multiply negative y times y, which is negative y squared. And then we're going to do 1 times negative x squared, which is minus x squared, divided by 1 times y, which is y. But then this all has to be divided by y squared. The y came from 1 times y. Remember, you cross multiply this way, you cross multiply that way, and then you have to multiply the two denominators too. Now, when I divide by y squared, that's the same thing as dividing by y squared over 1. Which means you have to multiply, I'm sorry, I'm running out of room, you guys. Multiply by 1 over y squared, which means on the top here I have to multiply by 1 over y squared too. So we have this numerator that has to be multiplied by 1. That's not bad. Leave it like that. So we have negative y squared minus x squared divided by y times y squared, which is y cubed. All right, now this is the part that's going to kind of throw you guys for a loop a little bit. As if it didn't already, right? Can you guys help me transfer that answer onto my next page here? What was it? Negative y squared minus
X squared over y cubed.
That was it?
Yeah.
Okay. The original problem that we started with, I believe, was x squared plus y squared is equal to 25. Now, it just so happens that in this case, we end up with this, which can also be written as negative 1 times y squared plus x squared over y cubed. So, do you see what I just did? I took a negative 1 out, left me with y squared plus x squared. Well, y squared plus x squared is what?
25.
It is 25. So this is actually equal to negative 1 times 25 divided by y cubed, which can better be written. Yes, I can. Negative 1 times 25 is negative 25 over y cubed. This is your second derivative. Now this is the deal. This is what I'm just gonna admit, this is what I hate about these problems. Is how do you know that that's gonna happen? Well, sometimes it happens and sometimes it doesn't happen. You know? I'm sorry, but that's just how it is. That one wasn't that hard to find. Sometimes they're harder to find. Sometimes you can't do it at all. What did you say?
That wasn't hard.
That wasn't hard? Oh,
Stop lying. That was hard.
some of you, okay. Some
He's
of
being
you are-
sarcastic.
Okay. Yes.
How do you know when you can't take the second derivative? Like, at what point would you know that you just stop because it won't be there?
Well, when you figure that out, Joey, let me know. know what to tell you. You just have to explore, and when you can't do anything else, you stop. Okay?
So you could keep doing it again. That one, do the quotient rule again.
Oh no, okay.
That's no, if you're doing the third derivative.
Third derivative, you would do the quotient rule again. Yes, but I'm not asking you to do that. Now, let's talk about what were to happen. Let's say you kept going and going and going, and let's say you got to this. Let's say you stopped there. You didn't realize that inside of there was a 25. I'm fine with that. You are not going to fail the test because you didn't know that. But if you find it, good, do it. Go for it. But if it's hidden, if it's really obvious, if the top said x squared plus y squared, and you didn't realize that was equal to 25, I would probably take some points off for that. But this is a little obscure. You might have to do some digging to find what you're looking for. So I would probably accept this answer, without taking the negative one out. Yes, Christina.
How did you get y cubed?
I got y cubed. If I go back to this page, I got y cubed by doing, I had to take this numerator times 1, which left me with negative y squared minus x squared. And then in the denominator, I had to multiply the denominator's y times y squared. Okay, that'd be y cubed. All right, yes.
You go back to the other page.
To the second page?
Is your second derivative the negative 25 both for y third, y
Yes.
cubed?
Yes.
So like if you don't see that there's like you can replace something, does that mean like we technically didn't reach it?
Oh, no. It just means that no, it doesn't mean that. It just means that there just happens to not be something that we can fit the original function back into the problem. That doesn't necessarily mean that you didn't find it. It just means that there's no hidden parts in there. And that will happen. I would say that happens as often as it does happen as often as it doesn't happen. Okay? Just be looking for it. We're missing like 5 kids today, which is why it's quiet in here. Key players. I am like loving this.
His phone is plugged up because it will not stop flashing.
What does?
That's Maddie's phone. Put your phone over there.
Is your phone plugged in right now?